solving chemical problems. Most chemistry problems end up being unit conversion problems. Other problems, you need to use specific equations. The ones we've done so far have used equations. We did some temperature conversions, those require an equation. We calculated the density, that requires an equation. But for unit conversion problems, we're going to do something called dimensional analysis. So we're analyzing the dimensions. I'm going to show you how the units can tell you what math to do with the numbers. Most people find this a bit confusing at first, but please keep asking and asking and asking. I even have some little cutout things that we can play with in lab. Once you see it, you'll just be blown away. Like, oh my goodness. This is the most important thing I learned in high school. I learned it in physics class as a junior. Teacher said, you can really solve most physics problems by just looking at the numbers with the units that they gave you, and you need this unit on the end, and you just figure out how to put these things together so the units work out, and there you go. You don't actually need the equation. So cool, right? Of course, it doesn't work in real life because they don't just give you the numbers that you need. Units should always be included in calculations. It's just a couple extra letters to write down, but it can mean the difference between getting the answer correct and getting the answer wrong. And enough of those are going to result in passing the class or not passing the class. Units act like algebraic variables. They can be multiplied, divided, they can be canceled, right? Okay, so what we call a unit equation is just a statement of two equivalent quantities. So we can say that 2.54 centimeters is equal to 1 inch. So this is the same length, it just has two different names. We can call it 1 inch, we can call it 2.54 centimeters. They mean the same thing, okay? We can take that unit equation and make it into a conversion factor. So what we can do, take this 2.54 centimeters is equal to 1 inch. So that's an equality. If I do the same thing to both sides of that, it's still equal. So what if I divide this side by 2.54 centimeters, and I divide that by 2.54 centimeters? Well, what happens over here? 2.54 divided by 2.54 is 1, right? Those cancel out. And centimeter divided by centimeter is 1. And so this is numerically equal to 1. If I take 5 and multiply by 1, what is it? It's still 5. This doesn't look like 1, but it is. It's equal to 1. We can also do it the other way. Divide both sides by 1 inch. And now the ones and the inches cancel out. 2.54 centimeters divided by 1 inch is also equal to 1. So I can take either of these conversion factors and multiply a length by it, and I can change the unit without changing the actual length. So that's what we're doing with dimensional analysis. So most of these are going to take this form. You're given some information, you're given a particular unit, and then they're going to ask you to find something with a specific unit. And so you're going to find or create a conversion factor with the desired unit on the top and the given unit on the bottom. Because when we take this unit and divide by the same unit, it cancels out. So let's do this example. How many centimeters are in 12 inches? So what are the numbers in this problem? Well, there's only one, 12 inches. And what do they want us to find? Centimeters. So I'm going to start with my number, 12 inches. What I want to do is I want to multiply by the unit I'm trying to get, and I'm going to divide by the unit I was given, because inches divided by inches cancels out, right? So we put the units in first, and then the units tell me where the numbers go. Because what we remember is that 2.54 centimeters is equal to 1 inch. So in this conversion factor, whatever is on top of the fraction has to be equal to what's on the bottom. So here we have the centimeter part. Well, by looking at the units, we figured out that part needs to go on top, and this part needs to go on the bottom. So I'm just going to put this number with the unit after I decided where the unit needed to be. And now I've got 12 times 2.54 divided by 1. So 30.48, and the only unit left is centimeters. Now practice your sig figs here. How many significant figures does 12 inches have? 2. It's real tempting to say it's an exact number because it's a whole number. It's this nice whole number, 12. But inches is something that's measured, not counted. 2 sig figs. So then in my answer, well then I've got this one, which looks like it has 3 sig figs. What this is saying is that exactly 1 inch, that's not what I meant to do, exactly 1 inch is equal to 2.54 centimeters. This is one of the few conversions between metric and English that are exact, because they got tired of it and said, let's just slightly redefine the inch so that it's exactly 2.54 centimeters and be done with all of this business. So this is actually an exact number, and so when we're doing the sig figs, anything that's an exact number, we just don't even have to think about. That's an exact number, it's not going to change anything. I started with 2, I end with 2. So if I write 30 centimeters, is that a good answer? What about that 0? Is that a significant 0? It's ambiguous, right? So one thing we can do, if it has a decimal point, it's no longer ambiguous. Looks kind of dumb, but the better thing to do is scientific notation. That's going to be 3.0 times 10 to the 1 centimeters. Any questions? So for those of you that like steps, here's a general problem-solving strategy. Everybody struggles with problem solving at some level, and we can all become better at it. And so this is a suggestion on how to become better at it. You don't get better at something by doing stuff that's easy, right? If you want your muscles to be stronger, you can't just do wimpy little exercises that cause no pain, right? You have to work hard, you have to get sweaty, and you're going to get sore. If you want to get better at problem solving, then you have to do some hard work, and you might get sweaty, and you might get sore, and you might get a little angry, right? But you'll figure it out, and then you'll become better at it, okay? So we want to identify the starting point, the given information. Usually this is numbers. Write those numbers down. Always write down the units. Sometimes you'll be given some per units, like grams per milliliter. Those are often end up being your conversion factors. So you figure out where you're starting, and then you want to figure out where you're going to end. So this reminds me of I went to visit a friend in the Bay Area, and we were going to meet at Starbucks at the Stanford Mall. So you drive to the mall, and you park your car, and you go up towards the mall, and you see one of these big signs with a map, right? You are here. it's very important to know where you are so that you can figure out where you can get where you want to go, right? Because the map would be no good if I didn't know where I was. So we have to know where we're starting, and then we have to know where we're going, and then we can figure out how to go. I'm not going to be able to use this much longer, but did you guys watch Dora the Explorer when you were little? Okay, phew. So what did Dora do? What did she do when she didn't know where to go? Who did she call? The map, right? And map would come out and say, oh, well, you want to get to the snowy forest? Well, first you have to cross the bridge, and then you have to go through the scary woods, and then you get to the snowy forest, right? So after we figure out where we are and where we want to go, we're going to figure out how we're going to get there, the map, okay? So the map is going to have steps, do this, this, and this, and then we're just going to follow the steps. So to solve, we're going to follow the plan. We're going to use a calculator. I mean, you're welcome to practice math in your head, but check it with the calculator, okay? It's so sad when somebody does this beautiful work and they get the answer wrong because they added 2 and 2 and got 5 or something. I mean, we all do stuff like that, but you have a calculator, use it. Do the calculation twice. Why? Because sometimes you multiply instead of dividing, right? And then at the end, check. Does it make sense? Are the units what I was trying to get? So those are that's the plan, the strategy. Okay, so let's do an example here. Convert 288 centimeters to yards. So this is a word problem with very few words. There's no like big long background story on here. We're going to save those for later. We'll keep all the confusing words out of it for now. I read the problem. What am I given? I'm given 288 centimeters. So I'm going to write that down. 288 centimeters. What do I want to find? Yards, right? Convert centimeters to yards. So this is where I am. This is where Dora is starting. And Dora wants to go to yards. And we have to figure out how to get there. Well, if you happen to know in your head how many centimeters are in a yard, piece of cake, one step. I don't know that. So we're going to have to go to a different unit in between. Centimeter is a metric unit, right? Yard is an English unit. So at some point I have to jump from metric to English. Well, can I do that with centimeters? Do I know the relationship between centimeters and an English unit? We just did an example, centimeters and inches. And, maybe you don't remember that. We'll go back and look at that, table 1.3. Pretty much anything you need is going to be on there. Okay, so I know how to go from centimeters to inches. And then I have to say, well, do I know how many inches are in a yard? I happen to know that, but maybe you don't. Let's pretend we don't. Well, there's another unit in there, isn't there? What's the unit that's between inches and yards? Feet. So if I converted inches to feet, I'm hoping everyone knows this. 12, what happened? 12 inches is equal to 1 foot. How many feet in a yard? 3. So 1 yard equals 3 feet. If you forget that on an exam, ask me and I'll tell you. So there's our path. The map is saying if you start at centimeters and go to inches and then go to feet, you can get to yards. Okay? That's the hardest part of the problem. Making the plan, figuring out on the map, where am I going? We're going to take this and we're going to turn it into an equation. We're going to do this all in one equation so we don't have to write down intermediate values. So we copy down the number and unit that we're starting with. And then you look at how many arrows are there. I have 1, 2, 3 arrows. I'm going to need 3 conversion factors. That's 3 fractions. Times and a line, times and a line, times and a third line. 3 arrows, 3 times lines. These are the units that go on the top of those things. I already have centimeters. Centimeters to inches. Next is feet, and next is yards. It's pretty straightforward, right? What I want to do is I want this unit of centimeter to go away. I need to get rid of most of these units. So the way to get rid of centimeters is over here. I'm going to divide by centimeters. Because centimeters divided by centimeters cancels out, gone. How do I get rid of inches? Divide by inches. Cancels out. Don't scribble them out, just draw a single line through them. You still need to look at them. And then feet, I'm going to divide by feet. You okay with that? So I analyzed the dimensions. I got all the units figured out. My units are all going to cancel out. I'm going to end up with the unit that I was trying to find. Now, the units are going to tell me where to put the numbers. So much less thinking. So here, inches and centimeters. Well, in that unit equation, what is the number with centimeter? It's 2.54. Well, it needs to stay with centimeters. So 2.54 goes down here because that's where I wrote centimeter. The number on the other side with the inch is 1, and so I've got 1 inch up there. This one is feet and inches. 12 inches equals 1 foot. What's on the top equals what's on the bottom. We can't say that 12 feet equals 1 inch, right? It's just not true. 12 inches is a foot. And then here, 1 yard is 3 feet. 1 yard on the top, 3 feet on the bottom. So now we just need our calculators. Sometimes students want to multiply all the numerators and write it down, and multiply all the denominators and write it down in a separate fraction, and then divide them. That does work. In my experience, every time I write something down, I can make a mistake. Every time I take that number and I punch it into my calculator, I could make another mistake, right? And then I'm going to do that with the bottom two, and I have a lot more opportunities for mistakes. What I want you to do is you start with the first number. You go to the next thing. You multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom, all the way across. Do I actually have to multiply by 1? No, multiplying or dividing by 1 doesn't change anything. So some people are good with, well, I can skip that. So times 1, but I can skip that. I divide by this, times 1, I'll skip that, divide by this. Times 1, I can skip that, divide by this. That's fine. If you don't want to skip that, go ahead and multiply and divide by 1. It's not going to hurt anything. It's just whatever works for you, okay? So I'm going to do the ones. 288 times 1 divided by 2.54. I'm not going to press equals or anything. Times 1 divided by 12 times 1 divided by 3. And now I'm going to press equals. And before I start writing this down, I'm going to ask myself, well, how many significant figures is my answer going to have? Well, how many did I start with? 3. Right? It's not exact because you can't count centimeters. Is this an exact conversion? Yeah, I just told you it was. How about this one? This is within the English system. It's exact. This is within the English system. That's exact. It means that all those conversion factors are exact, so I don't have to think about them at all. I started with 3 sig figs, I'm going to end up with 3 sig figs. So I'm going to take this number that it's giving me, and I'm going to write down the first 3 digits, 3.14, underline that, that's my last significant figure, and then I'm going to write down the next 2 digits and the unit. Then I'm going to round it. So I'm dropping the 9, so I have to round the 4 up to a 5, 3.15 yards. Showing your work is really important. You don't have to write out the path. If you're just getting started or if you're having trouble, write the path out. But once you get the hang of it, you won't need to do that. But this part is really important. Don't try to just do that in your head. Literally write it out. There's a lot of things that are good about that. If you make a mistake, you can go back and look, well, did I set up the calculation correct? Maybe you got the 1 and the 3 switched. No, the calculation is set up correctly. Well, let me punch it through on my calculator again. Maybe I pushed a button wrong. If you don't write anything down and you just do the answer and it's wrong, you have to start all over again, right? Showing your work, super, super important. Any questions about that one? .15 yards. So we learned how to use the units to convert, and now we're going to look at conversions using metric prefixes. So we can make these unit equations just by knowing what the metric prefix stands for. So 1 kilometer equals blank meters. Well, we're going to look up what does kilo mean, and this is why I'm asking you to memorize these things, because at least the main 4 we're going to use a lot. So the lowercase k is an abbreviation for essentially times 10 to the 3. So 1 kilometer is 1 times 10 to the 3 meters. There are other ways to do it, but I'm just going to show this one way. Doing it this way, the prefix goes on one side, there's the prefix, the multiplier, the 10 to the something goes on the other side. You never ever put them together. Okay. Now, is it true that a meter is 1/1000th of a kilometer? Sure. And if you remember 100 centimeters is a meter and you want to do it that way, that's absolutely fine. But I'm not going to ever do that on the slides or in lecture, because this way, if you follow the rule, it works every time and you don't have to think about it. So the prefix on one side, the 10 to the something on the other. If you have to convert between units where both of them have prefixes, so you have 2 prefixes, like centimeters to kilometers. 2 prefixes means do it in 2 steps. Of course, it could be done in 1 step. It involves way more thinking. It's easy to get backwards. It's actually faster to just do the 2 stupid steps. Okay? 2 prefixes, 2 steps. 1 prefix, 1 step. Okay? So let's do this example, centimeters to nanometers. So I'm looking at what I've got here. I'm going from centimeters. This may be a little bit silly here. From centimeters to nanometers. So the prefix, the unit I'm starting with has a prefix and the ending ones. 2 prefixes, so 2 steps. So I'm going to start with the centimeters, and I'm going to go to the unit without a prefix. And then from that one, I'm going to go to the other prefix. Okay? So let's do a unit conversion with 1 prefix. So convert 0.00423 liters to milliliters. So this is going to be 1 step. 0.00423 liters, and I can go directly to milliliters. So there's my path, very simple. There's only one arrow, so I'm only going to have one fraction. And the units, I start with liters and I go to milliliters. So milliliters goes on the top here, and what do I put in the bottom? Liters. I take the previous unit and I put it down here because I want those to cancel out and go away. So now I'm looking at my conversion factor here. This one has the prefix on the top. I can look it up if I haven't memorized it. Milli stands for 10 to the minus 3. Milli is on the top. I'm going to write what it means on the other side. Never put them together. So that means 10 to the minus 3. So 1 milliliter is 1 times 10 to the minus 3 liters. And thinking is good, but I'm all for having things where you don't have to think. Right? So there's our equation. We need to do this on our calculator. This is a number in scientific notation. Your calculator has a special button for that. There's more than one way to enter scientific notation. You could do 1 times 10 raised to the 3rd power. But we're going to be using this a lot, and if you do it that way, you're going to run into trouble, especially when we start getting a little more complicated. So what you want to use is your scientific notation button. Some calculators, it's EE. On some, it's EXP. And then there's a select few that call it times 10 to the x. But as you press one of these buttons, this stands for times 10 to the. So as you press that button, you say times 10 to the. So to enter this thing on the bottom, I'm going to go 1 EE minus 3. So on my calculator, I'm going to do 0.00423 times 1 divided by, and this is going to be 1, let's make it a different color, 1, and that EE button, and minus 3. And I'm going to get 4.23. Is anybody having trouble getting their calculator to? Yeah, so I took the 0.00423 times 1 for the numerator, and then divide by 1 EE negative 3. So make sure your calculator is cooperating, and if it isn't, I'll come and yell at it. I don't yell at it, but I'll speak sternly to it. You press the EE button once, and it'll give you 1 E. Yeah, it's kind of weird. The button has 2 E's. When you push it, you only get 1 E. Yeah, you only need to press it once. Great question. Make sure your calculator's cooperating. Does anybody need to borrow a calculator? I mean, you can use the calculator on your cell phone or on your tablet, but an actual calculator is a lot better. If anybody needs one, we've got a classroom set you can use. So in terms of significant figures, because this is within the metric system, sig figs we don't have to think about. And so we look at, well, how many sig figs were in this first number? 3. The leading zeros don't count. So this had 3 significant figures, and my answer is going to have 3 significant figures. Let's do one that has two prefixes. If we have two prefixes, how many steps? 2 steps. So I've got the number that I'm starting with, 5.52 times 10 to the minus 5 centiseconds. And I'm trying to get to microseconds. So the step in the middle will be just seconds without a prefix. So I'm going to go centiseconds to seconds, and then seconds to microseconds. And yeah, it's 2 steps, but it's faster than trying to figure out how to do it in 1 step. So 5.52 times 10 to the minus 5 centiseconds. I look at the path, 2 arrows, 2 fractions. Times in a line, times in a line. So my path here is exactly what units are going to go in my equation. Here's centiseconds, and next is seconds, and then microseconds. So once you get this, it's really all downhill from there. So I need this one to disappear, so I take this unit and it goes in the denominator of the next term so that those will cancel out. This second here, I'm going to put down here so they cancel out. All the units are working. Now I use the units to tell me where to put the numbers. So here I have seconds and centiseconds. I need to know what C stands for. So C represents 10 to the minus 2. So I have the C on the bottom, so I'm going to put the 10 to the minus 2 on the other side of the line. 1 times 10 to the minus 2 seconds is equal to 1 centisecond. Here I've got micro, that mu. That stands for 10 to the minus 6. So I've got the mu up here. That's like an abbreviation for 10 to the minus 6. 1 microsecond is 1 times 10 to the minus 6 seconds. So now I'm going to use my calculator again. So putting this number in, 5.52, press the EE button once, or the EXP button. On mine, it just shows me 1 E. That's fine. Yours might show you something else. They all do it a little differently. And then I'm going to put in the negative 5 exponent. On my calculator, I have a button down at the bottom that looks like this. There's another button over on the side that looks like this. This is the minus sign, and this is the sign you use for a negative number. Some calculators have one like that, change sign. So these are the guys you want to use to get those negative exponents. So 5.52, the EE button, negative 5. Times what's on the top, 1 EE, negative 2. Divide by the bottom, which is 1. Multiply by the top, which is 1. Divide by 1 EE, negative 6. Zero 0.552, and the only unit not crossed out is microseconds. Is your calculator working? I found people towards the end of 1B last spring that were still using scientific notation in a very roundabout, difficult way, which makes me sad, because I just think of all the extra button pushes they did over the course of 2 semesters. And in my mind, every time you push a button, you could do it wrong, right? So fewer button pushes, fewer errors. What about units raised to a power? These don't come up a lot later in the semester, but they will show up on this first exam, and they could show up on the final. So if we have units raised to a power, like for area or for volume, what we're going to do is we're going to start with the same unit equation. So if we're doing square centimeters to square inches, we're going to start with centimeters to inches. And then we're going to square both sides. We're going to square the number and the unit. Squaring the number and the unit. Now on this side, squaring 1 is still 1. And so that messes with your head sometimes. This is 1 square inch. Over here, 2.54 squared is 6.45 square centimeters. And so now this is a relationship that you can use. The reason it's like that is if we think about this area here, it's 1 inch squared. Well, an inch is 2.54 centimeters. And the other dimension is also 2.54 centimeters. So the volume is going to equal 1 inch times 1 inch, which is 1 square inch, or 2.54 centimeters times 2.54 centimeters, which equals 2.54 squared centimeters squared, or 6.45 square centimeters. So you have to square the unit. If you're cubing the unit, you cube the number. If you square the unit, you square the number. How many cubic centimeters are there in 2.11 cubic yards? Well, we're trying to find cubic centimeters. We're starting with 2.11 cubic yards. So let's write down where we're beginning, 2.11 cubic yards, and where we're going to end. We're going to end up with centimeters cubed. And to figure out what this path is, let's just pretend the cube isn't there for now. The path is going to be just like yards to centimeters, except we're going to end up cubing everything. So how can I get from yards to centimeters? We did centimeters to yards a few minutes ago. Yeah, we could do yards to feet and feet to inches. Yeah? So if we can do yards to feet to inches to centimeters, we can also do yards cubed to feet cubed to inches cubed to centimeters cubed. So 2.11 yards cubed, 3 arrows, 3 fractions. So here I've got feet cubed, inches cubed, centimeters cubed. So I'm going to put those units in here. Put those units in here. Those cancel out. These cancel out. We just need to be a little careful when we're using the numbers. 1 yard is equal to 3 feet. If I cube both sides, 1 cubed is still 1, and yard cubed is yard cubed. What's 3 cubed? 3 times 3 times 3 is 27. So that's 27 cubic feet. If you look at the older videos, the way I've done it in the past is I put the 3 and the 1 in here, and then I cube the whole thing. I'm just doing it a little different this time to see if maybe that'll save some problems. So 1 cubic yard is 27 cubic feet. And then I need to go from feet to inches. 1 foot equals 12 inches. But I need cubic feet and cubic inches. So I'm going to cube this side, and I'm going to cube that side. What's kind of confusing is that one of the sides is still 1, and the other side the number changes. You just have to accept that. So here, what I want is 12 cubed inches. So 12 to the 3rd power, or 12 times 12 times 12, it's 1,728 cubic inches. I ran out of space, I'll do it on the top here. 2.54 centimeters is equal to 1 inch. Cube both sides. So I'm going to get 1 cubic inch on this side, and 2.54 cubed is 16.387064 cubic centimeters. So, the numbers here can get a little messy. If you prefer to just put in 2.54 cubed, so 2.54 cubed is 1 inch cubed, you could do that too. But what happens a lot is that people cube the units and they forget to cube the numbers. The number has to be cubed. Okay? So we're just going to go with a little more straightforward, and I'm just going to go ahead and type that number in there. 16.387064. So I've got 2.11 times 27 divided by 1 times 1728 divided by 1 times 16.387064 equals. So my calculator is showing me a big mess. How many sig figs should that have?
3.
Should have 3. This is English to English, that's exact. This is English to English, that's exact. This one's centimeters to inches, also exact. Which is why I wrote down all the stupid digits there. So starting with 3, I should end with 3. So I want to keep the 1, the 6, and the 1. Whoops, writing in the wrong place. I am rounding in a place that's much bigger than the 1's place.
Well, you should use scientific notation.
I should use scientific notation. That is the absolute best thing to do. Because I don't want to accidentally do something dumb and say this is 161. Because it's actually 1,600,000, right? It's not even close to 161. So I'm rounding to a decimal place over here somewhere. I'm going to put it into scientific notation and round it at the same time. And I did not plan my use of space here. So I write the first non-zero digit, I put a decimal point, and I write the next two digits, and then I double check what's the one I'm dropping. It's a 3. Okay, I don't have to do anything. Those are the 3 I'm keeping, times 10 to the, and the decimal point started here. I don't want to start at the end. I want to start where the decimal point actually was. And I'm going to see how many places did it move. 1, 2, 3, 4, 5, 6. So my exponent is 6. Positive 6 or negative 6? Positive. That's a big number. I feel very positive about big paychecks, right? That'd be an awesome paycheck. Let's bring it, right? Yeah. Maybe if I win the lottery. So there's my number, and then I need the correct units, and there's my answer. Yes?
Docus points if you wrote it as 16.1 times 2
I would not dock you points, but I would wonder what you're doing. I think that's actually engineering notation with the 2 digits before the decimal point, but this is science, not engineering. I've seen all kinds of weird things. I'd probably give you credit for it, but I'd ask you, what were you doing? The thing about scientific notation is there is one correct way to represent the number in scientific notation. If we could choose how many places we put before how many digits we put before the decimal point, then we could have lots of different results, right? So there's always just one way, okay? I would know what you mean, right? If you type it in on the computer's gonna say it's wrong, because it is really picky and it's just not very compassionate. Yeah, but that's a great question. Any other questions? (1.61 times 10 to the 6th). There's so many examples here, but they kind of get repetitive. The thing about this one, I'm just going to kind of talk about it instead of doing the whole thing, because we want to get to the worksheet. So we would read through this one. This is one that has a lot more words in it, right? It kind of has a story going. A vineyard has 145 acres of Chardonnay grapes. I mean, do we care that they're Chardonnay grapes? No, we don't. A particular soil supplement requires 5.5 grams for every square meter of vineyard. How many kilograms of the soil supplement are required for the entire vineyard? Now, does that sound like an actual real world kind of problem? It does, right? Unit conversions like this are useful in everyday life. This one is not as straightforward as the last one. So I'm going to show you how to pick it apart. So we're going to highlight all the numbers with all of their units. And we've got this guy over here. That's a conversion factor. Put in there so you don't have to go look it up. And then what are we trying to find? Kilograms of soil supplement. Okay, so we've got more than one number here, right? So we can't just say, oh, that's the number in unit, that's what we're starting with. We've got a bunch of things. So let's write them down. I have 145 acres. That's one of the things. Here's another thing, 5.50 grams for every square meter. That's the same as per, right? Grams per square meter. So let's write that as a vertical fraction, grams per square meter. And then I've got this relationship at the end 1 square kilometer is equal to 247 acres. Now the tricky thing is, which of those is my starting point? They can't all be the starting point. We can only start at one place. Almost always, it's going to be the one with the simplest unit. This one is just acre. Come on, pointer. Acre. This is grams per square meter, which could be used as a conversion factor, right? Because that is the same as 5.50 grams is equal to 1 square meter in this situation. And then this was a conversion factor that was given to us. So anytime you have per or for each, mostly it's per, that's probably going to be your conversion factor. So this is the guy I'm starting with. So I'm actually going to start with my acres. And then I'm going to, the green here, kilograms. So I'm trying to get to kilograms. This one is different because this is not just unit relationships I look up in a table or use metric prefixes for. These are some specialized relationships for this problem only. I need to get from acres to kilograms, from an area to a mass. Well, let's look at what they gave us. They gave us square kilometers to acres. Oh, here I've got acres. So this would let me go to square kilometers, right? So I could do that. Kilometers squared. And this other thing they gave me doesn't have square kilometers in it. Sometimes you then have to go to the end and work your way backward. This is the challenging part, is to figure out the path. Kilograms. Oh, well, they gave me this relationship, but that's not kilograms either, but it's grams to square meters. Well, could I convert kilograms to grams? Yeah. So here at the end, if I got to grams, then I could go to kilograms. We learned how to do that. This is going to get me between grams and square meters. So square meters to grams. Oh, could I do square kilometers to square meters? No, we just learned how to do that. Because we can do kilometers to meters. So we just need to take that and square it. Okay, so then I get that path. So this one's kind of messy looking, huh? Any questions about the process of setting that up? Do you want me to finish it? Yeah? Okay. Let's finish it. So we did the hard part, might as well just finish it off. So I'm going to start by writing down what I've got at the beginning there. 145 acres. And I've got 1, 2, 3, 4 fractions this time. 1, 2, 3, 4. But again, I'm just going to take those units and copy them down. Very little thinking here. Acres to square kilometers. I hear the map talking to Dora. Then you go to square meters, and then you go to grams, and then you go to kilograms. So the next step was to take the first unit and divide by that unit so they cancel out. So I'm going to put acres down here. Those cancel out. And then kilometers squared comes down here. So those cancel out. And then I'm going to put meters squared down here. Oops. Meters are going to cancel out. and grams down here, and grams are gonna cancel out. I've got all my units, they're all canceling out, and the only unit that's left is the one I'm trying to find. Right? Now, some of these are gonna be easier to put numbers into than others. It doesn't matter which order you do them in. I like to do the easy ones first, makes me feel better. This one is going to be fairly easy because they gave it to us, right? And I just rewrote it over here. So where do I have grams and square meters? Oh, that's this guy right here. So what number was with gram? 5.50. And what number was with square meters? 1. This one also is pretty easy because they just told us that. So that's this first one, square kilometers to acres. Well, it was 1 meter squared. I'm sorry, 1 kilometer squared. Got it in the wrong place. 1 kilometer squared was 247 acres. That square to square one that one's kind of messy. Let's go to the last one. So here I have grams, kilo on one side and nothing on the other. What does kilo stand for? 10 to the 3. So kilos on the top, I'm going to write 10 to the 3 on the bottom. Because these mean the same thing. 1 kilogram is 1 times 10 to the 3rd grams. This is like someone's given name, and this is like their nickname. Okay? Okay, so now we got this guy left. So let's do a little writing on the side here. And let's think about meters to kilometers first. Well, kilo means 10 to the 3. So 1 kilometer is 1 times 10 to the 3 meters. Here, it's squared. So I need to square this and square that. So this is 1 squared, which is still 1 kilometers squared. This is going to be 1 times 10 to the 3 squared meters squared. Oh, how do you do that? Well, one way is just to do 1 EE3, 1 times 10 to the 3, times 1 EE3, and write down what it shows you. Now mine's giving me a whole bunch of zeros. It's telling me 1, 2, 3, 4, 5, 6 square meters. If I put that in scientific notation, that's 1 times 10 to the 6 square meters. Your calculator probably has a fairly easy way of taking that display and changing it to scientific notation and then changing it back. And so if you want some help figuring that out, I'd be happy to show it to you. So 1 kilometer squared is 1 times 10 to the 6th meters squared. Are there shortcuts you could take? Could you do some of this by adding and subtracting exponents and stuff? Sure, you could. And if you're good at that, go for it. But you can also just punch it through on your calculator. So this is 145 times 1 divided by 247 times 1 EE6 divided by 1 times 5.50 divided by 1 times 1 divided by 1 EE3 equals, and I'm kind of getting a mess again, 3228 point stuff. How many sig figs should my answer have? How many did the first number have? 145. 3. Again, with a whole number, it's tempting to say, oh, exact number. But an acre is a unit of land. It's not a physical object, a discrete object. So 3 sig figs there. How about this relationship? Anytime you have a 1, that's going to be exact. They're saying exactly 1 square kilometer is 247 acres. So that would be 3 sig figs. This is in the metric system, so that's exact. This is not in the metric system. It's a soil supplement mass per area. So this would be 5.503 sig figs. That's exact. So I've got 3, 3, and 3. My answer should have 3 then, right? So I'm going to write down 2 extra digits. And then I want to be careful when I round this, because it's in the tens place. So let's put it in scientific notation, 3.228. So I have to change the 2 to a 3 because the next digit is greater than 5. So 3.23 times 10 to the 1, 2, 3 kilograms of soil supplement. It's a big number, it's a positive exponent. These take practice. Okay? And so what we're going to do with the worksheet is you're going to practice. And then you can check on the quiz on Canvas to see if you got the answer right. If you didn't get the answer right, go back and look at your work and see if you can. It just take a couple minutes. Don't spend an hour trying to figure out where you went wrong. It's a waste of your time. But spend a minute or two and look at it. If you can't figure it out, ask me for help or ask your neighbor. Do you see what I did wrong here? Because when you make those mistakes, then you can learn from them so that you don't keep making the same mistakes over and over again. You can go on to make new and different mistakes, right? We all make mistakes all the time. Just a little note about sig figs. I really want you to give sig figs a good old college try, right? And keep trying. But significant figures are not the end-all be-all of chemistry, okay? We need to keep trying at them, but after the first exam, the exam questions will not be specifically about significant figures, okay? So I'll just give you a couple of hacks, right? Most of the time, however many significant figures the starting thing has, that's what you're going to end up at the end. Most of the time. Not every time. Definitely not on this worksheet with the sig fig questions. They're meant to be tricky. But when you're doing these other kinds of questions, it's usually the same as the starting number. It is often 3 or 4. We'll find in, all of these problems that we do, oftentimes it'll be 3 or 4 significant figures. Things are a little bit different in lab, but in the book and homework and stuff, it's usually 3 or 4. Okay, let's make sure I didn't leave out anything really important in the rest of this. Oh, yeah, I gotta do this. Okay, I told you earlier, we use the density equation to calculate the density. We don't use it for anything else. Now, you may have been taught to draw the triangle, and so mass is volume over density or whatever. In my experience, students mess that up more than they get it correct. And you don't need to do that. So I'm going to show you how you use density just as a regular conversion factor, and you don't have to think about any algebra. So here's another one. Backpackers often use canisters of white gas to fuel a cooking stove's burner. Nice. Do we care about that? No, actually we don't. One canister contains 1.45 liters of white gas, and the density of the gas is 0.710 grams per cubic centimeters. What is the mass of the fuel in kilograms? We read all the words, we highlight the numbers with their units, we highlight the question. We take those numbers and units and we write them down. 1.45 liters, 0.710 grams per cubic centimeter. This is written horizontally with a slash because it's easier to type on a computer. That's the only reason. And then students often write it down the same way, and then your brain doesn't recognize that's a fraction. So when you copy it down, it's just as easy with your hand to make it a vertical fraction as it is a horizontal one. So that's 0.710 grams over cubic centimeters. Well, how many cubic centimeters? It's per each cubic centimeter, per one. So if you feel like, well, that needs to have a number down there, it has a 1. And then I'm trying to find kilograms. Again, I've got 2 different numbers. I have to decide which one to start with. Right? I've got liters, and I've got grams per cubic centimeter. This one relates to different units. It's probably a conversion factor that I need. This can't possibly be a conversion factor, right? It's just liters, it's just sitting there. It's good for nothing else except starting this whole business. So that's my starting place. This is where I'm starting, and this is where I'm ending. This guy's going to be a conversion factor. So now I have to think, well, how can I get from liters to kilograms? We probably have to use this. This doesn't have liters or kilograms in it. But grams and kilograms are really close. So if I had grams, I could get to kilograms, right? This gives me the ability to change from cubic centimeters to grams. Yeah? What's another way to write, what's another unit that is exactly the same as cubic centimeters? Milliliters. Ooh, that sounds better, right? Liters to milliliters, these are the same. So what I can do is I can just say, well, I'm not going to use cubic centimeters, I'm going to use milliliters, and I can do that because it's the same thing. So I'm just going to go to this, and I don't have to think about that one. 1.45 liters. I have 1, 2, 3 fractions. 1, 2, 3 fractions. Liters to milliliters to grams to kilograms. The nice thing about the lecture videos is what you can do at home is you can go to the beginning of this part of, where I start this question, and then you can pause the video and you can try to do it without seeing what I did, without looking at your lecture notes. Just try to do it. And then if you're stuck, you press play and you watch me, oh, okay, I know how to do it from here, and stop, right? And so I can kind of hold your hand and you can get through it even without me being in your living room. Okay, so this unit comes down here. This is the same thing we've been doing. And milliliter comes down here, and grams comes down there. Okay? The same. And we're going to do the same thing for stoichiometry, and it's just going to work. Is the train going to come off the tracks? Or maybe that was a truck. I don't know, that was loud. I always wondered. I'm always afraid when I drive under the train tracks that that's going to be the moment when a train falls off. Right? And walking under there is even more scary. And so sometimes if I have to park in the parking garage and I come and it's like, oh, there's a train, I'll just pretend that I'm getting an important text message and I'll just stand there and like pretend that I'm doing something important until the train passes. And then I walk under because you never know.
My fear is like driving and scared that the bridge just collapse.
Oh, yeah. And that's even worse because there's bridges everywhere. Or you're on a bridge.
Yeah, I hate driving on bridges. I'm always
Or
scared.
you're on one of those exit ramps and there's this hill. And what if you just suddenly lost impulse control and turned to the right and just went down the cliff into the river? This is why I don't stand next to railings. Because what if you just, impulse control? I'll just throw myself over. Okay. Yeah, now you've got a picture into my crazy mind.
Final
Okay.
destination.
I don't do rock climbing.
That's definitely Final Destination. The real question is, do you get behind trucks like Final Destination?
Final destination.
That movie traumatized me, so absolutely not.
I would purposely.
I don't know
go
what
to
Final
school and-
Destination
You've
is.
never seen Final Destination?
No.
You talk about Dora the Explorer. You've never seen Final Destination.
No.
Oh my gosh.
I don't watch much television and I don't see very many movies.
It's like maybe early 2000s-ish.
I
It'll
had,
make you way more paranoid than you already are.
so probably I won't.
But,
Yeah.
but you kind of should because it's like, it'll make you think like, hey, I shouldn't be doing this. Yeah, I definitely shouldn't be doing that. So.
Yeah.
So, like,
I'll think about it.
So like
Yeah,
when you're driving behind a truck with a whole bunch of shit on it,
Mm-hmm.
do you drive behind it or do you go into the other lane?
Well, it kind of depends, but I do think about that could fall on me. I do
'Cause
think about it.
I purposely move into the other lane. I don't care if it's slower or whatever. I
But
am
see,
not
it could
going
also
behind
like fall to the side and get you over there. I don't need any more nightmares. I have these teacher nightmares where I'm late for my class and I go there and like the campus is all different and I can't find my class. It's kind of like some student dreams, right? Except I'm the one in charge here and there's, it's every semester. Okay, what were we doing? The stupid train or truck. Okay. It's a good thing we wrote this down.
I think it was one of those trucks that were pulling the other truck.
Yeah, probably. Okay, so milliliters and liters. It's a one prefix conversion. We just need to know, what does milli mean?
-2.
Good guess. No.
Oh. Other
-3.
2? Oh.
Centi is -2. Milli is -3. So this is a good way to start remembering these. Don't look it up first. Guess first. Then check it, right? So you think, I think it's -2. Well, look it up. You're gonna learn it faster than if you just look it up every single time. Okay. So it's 10 to the -3. So 1 milliliter is 1 times 10 to the -3 liters. Okay? Grams per milliliter. Well, that was given to us. We changed it up a little because we said, well, we could actually call that milliliters instead of cubic centimeters because they mean exactly the same thing. So 0.710 is with gram. So 0.710 still has to stay with gram. And it was 1 milliliter on the bottom. At the end here, I have kilograms and grams. What does kilo stand for? 10 to the 3. So 1 kilogram is 1 times 10 to the 3 grams. So then I've got 1.45 times 1 divided by 1 e -3 times 0.710 divided by 1 times 1 divided by 1 e3 equals 1.0295 kilograms. How many sig figs? 3. Our starting number had 3. This density is not exact, but it has 3. This is exact, that's exact. This is going to be 3, so it's 1.03 kilograms. We didn't have to rearrange the density equation. We treated it as a conversion factor. The units told us where they needed to be, and that told us that we're going to be multiplying by the density. On the worksheet, there were some density problems. If you're calculating density, use the density equation. That's it. Density equals this. If you're calculating mass, you're calculating volume, do not use the density equation. Do it this way. It's a conversion factor. Okay? Yes?
I have a quick question. I'm not sure if I just did something wrong with my calculator. I got 102.9. Not really sure where I went wrong.
You got 102?
Yeah.
Okay. I think I know what happened. So this is just a slide towards the end. Okay, so some problems do have equations. And then sometimes you have to use equations and dimensional analysis. Okay? So watch out for that. And these are some examples and some other extra examples.